Rough as Guts Videos returns to your screen with episode 3 of the enthralling saga of C pointers. In this case, I'm going to talk about pointers and their relationship to arrays. And hopefully I'll surprise you a little during this video. So I've got an array there, int data 10, 20, 30, no trouble so far. Let's have a pointer, int star. So p is a pointer that points at an integer, and let's initialize it to null, which isn't useful. It points at 0, which you can't get at. So let's make it useful by pointing it at somewhere vaguely relevant, in this case the address of data 0. Hopefully you're not surprised that p now points at element 0 of that array, and therefore you can print out the 0th item with a statement like that. Let's just double check it works, run it, it prints out 10, which is the 0th item of the array. So far so good. Let's also print a few more things. Let's print p, and I'm going to do something a little odd. I'm going to print data. You'll say, oh, but you can't print an array, and you'd be sort of right, sort of. Let's print it using a p format. I'll just do it first, and then I'll come back and talk about it. There it is. So there's star p, there's the value of p, there's the value of data. Same number. Well, that's a little bit odd. But what's happening here, you see, is what this statement on this overhead slide says, that the array name is actually just a way of, or it's just a reference to the 0th element of the array. So when you allocate memory for an array like this, the variable that you allocated is essentially just a pointer to the base of that. It's kind of exactly the same as p, except that you can't modify it, you can't assign to it or increment or anything like that, which you can do with p, as we'll show soon. So in the light of that, let's try a loop to print out the elements of an array in different ways. So there's our standard familiar for loop, no problem so far. Let's printf %d. I'm going to print it a few different ways, 3 for a start. I'm going to print it first of all as as data of I, which is the one you're familiar with. Then I'm going to, since data and p are kind of the same, you might expect that p of I would work. And I'm also going to print it using yet another notation, star p plus I. Let's just first of all compile it to make sure I got my code right, run it, and make sure we get 10, 10, 10. So printed it in 3 separate ways, same with the second and third elements. So what happened here? Let's stop and look at it. Data square brackets I is the ith element of data. Since data is pointed to the base of the array, and so is p because I set it there, that kind of might be expected to work, which it does. So this says using p as a pointer to the base of an array, index it by I. And this one says something sort of equivalent, which says go to the address at p plus I. So that's a new thing to you, using arithmetic on a pointer. What does it mean to add 1, say, to a pointer? And what it means is not necessarily that it adds 1 to the address. In this case, it adds 4 to the address because p is pointing at integers, and the mindset of the C designers, at least, was if we're going to point at integers and look and try and do arithmetic on it, we should move in lumps of equal to the size of the thing we're pointing at, in this case 4. So that's why those 3 work. Well, they do work, trust me, you saw it happen. This leads me to some other possibilities. What about star I plus p? Since p plus I should be equal to I plus p, you might reasonably expect that to work. Does that work? Let's find out. Whoops, %d that should have been. Let's compile. It seems to compile, always a good sign, and it seems to have done the same thing. So now I've got 4 separate ways of getting at the ith element of an array when I also have a pointer p pointing at the base of it. Now let's do something a little bit surprising. P square brackets I has been shown to be equivalent to star p plus I, and that in turn has been shown to be equivalent to that. So what about this? I square brackets p. What does that do? From the logic we just used, that should be equivalent. Maybe not. Maybe you think from the logic that we've had so far, sorry, I've got to put a %d in down here, you might think that's ridiculous. But this is C, and it works just fine. So we can go one step further than that. What about I indexed by data instead of data indexed by I? Let's put yet another %d in. How are we getting on here? Hopefully I've just about shattered all your confidence and belief in C as a high-level language. They all work just fine. So what's happening here is captured in the next slide. C doesn't really have arrays. You should stop thinking of them as being high-level data structures like in Java or Python. All we have is the ability to allocate lumps of memory. In this case, we allocated enough for 3 integers, 12 bytes, and getting pointers to them. And when you see indexing as an operation, data square brackets I, it's actually just doing pointer arithmetic, because that is exactly equivalent, well, better example, this here is exactly equivalent to that there. So p square brackets I is a notation meaning that. Please don't write the one that I've highlighted. Please always write that. And certainly don't write stuff like that. It's ridiculous. Yes, it works, but that's just a property of the low-level model that C has of pointers, of arrays, I should say, or whatever. So just one last thing I want to include in this video, and that's a follow-on from what you've just seen, a different way, again, of indexing through an array. So I'm going to do that by initializing p to the address at the base of the array. It was already in this example, but this is a more general version. And then I'm going to say while p is less than the address of data 3, there's 3 elements in the array, 0, 1 and 2. So data 3 is off the end. So that is essentially saying while p still lies within the array, incrementing p by 1 each time through by 1 integer, that's 4 bytes, I want to printf the thing that p points at, star p. So that goes through the elements of the array using, I've still got an error in my code, using a pointer. So I'm stepping the pointer through the elements of the array by updating it each time through. And that works fine too. There you see it, 10, 20, 30. The takeaways are that C doesn't have arrays in the sense that you've probably still been thinking. It only has lumps of memory, and an array variable is essentially a pointer to the base of that array, but you can't modify it. And then the indexing operations are just pointer arithmetic of the form I've shown you there. Thanks for watching. In the next video I will just tell you a little bit more about the implications of that for passing arrays as parameters, which we did last week. Thanks for watching. Bye.